Okay, so we're going to talk about how we sketch these polynomials here for a little bit. Okay, so the first thing we have to do is put on some axes. So let's do that first. Let me get my pen here. Okay, we get some axes going, an x and a y axis. Remember, this is the negative infinity on x. This is positive infinity. Positive infinity is up on y, and negative infinity is down. Okay, because the first thing we're talking about are the end behaviors, right? When x goes to infinity, so this is talking about the right side of your graph, we're going to negative infinity. In other words, the graph is going down on the right side. And on the left side of the graph, when x goes to negative infinity, the graph also goes down. So negative infinity on the left and a negative infinity on the right. So our next little bits are talking about where does it cross your x-axis? Okay, y equals 0 is your x-intercept. So negative 5, 1, 2, 3, 4, 5, has a multiplicity of 2, so it's going to bounce at positive 2. Okay, positive 2 has a multiplicity of 1, so it's going to cross there, and positive 8 has a multiplicity of 3, so it's going to flatten. It's going to flatten out here at positive 8. Okay, and then the next one tells you where it crosses the y-axis. When x is 0, y is negative 8. So we come down here and we put a negative 8 there. And now we can sketch it. Okay, so we know that it starts at negative infinity and it has to come up to negative 5 and bounce. Okay, somehow it makes it over here to negative 8, goes up through positive 2, comes back down towards, but it comes and it needs to cross flatly. Okay, so that's what it's like to have a flat cross rather than a normal cross. So there's your first one. Okay, so let's take a look at your second polynomial function here. Similar to what we were just doing, using those same attributes. So here we have your intercepts, or rather your axes. Positive infinity to the right, negative infinity left, negative infinity down, positive infinity up. Okay, so on the right side of the graph, it's at infinity. Okay, when x is infinity, y is infinity. And at the left side of the graph, it's negative infinity, so down on the left, up on the right. So third quadrant, it's down. First quadrant, it's up. So it crosses here, it looks like, at negative 3, has a multiplicity of 1. Okay, positive 3 has a multiplicity of 1. And positive 6 has a multiplicity of 3. So once again, it's going to cross in a flat wise. And then it crosses the y-axis at 7. So we'll put 7 right there. Okay, so now we have to sketch. It doesn't have to start exactly on your arrow. So I'm going to start mine here maybe. Okay, it's got to come up through 7, go down through positive 3, and then come back up towards 6. And when it does, it's going to come up and go through it flatly. Okay, so it doesn't have to hit your arrows. It just has to make sure that you go through the points. The points are more important than the arrows. Okay, so there's the final graph of that one. As ugly as it might be. Okay, but the points are right. So let's talk about your rational ones, because these ones are a little bit more involved. They have more to think about and to do. So here are your axes. Okay, it says our domain restriction is x is not equal to 0. Okay, which is great. But then it tells us here that the limit as x goes to 0 does not exist. So this is telling us that there is a vertical asymptote at 0. Okay, so there's your vertical asymptote. Now on the left side of 0, the graph is going down. Okay, this is your behavior around your asymptote. And to the right side of 0, right, plus, it's up here at positive infinity. On the left of 0 and on the right of 0. That's what those minuses and pluses mean. And then we have this one, as the limit as x goes to infinity. This is talking about your horizontal asymptotes. In this case, it's 5. So 1, 2, 3, 4, 5. Okay, there's your horizontal asymptote. Our next things are going to be your intercept. So this is your x-intercept at negative 2. It crosses your x-intercept, so only one time there, and it doesn't cross your y-axis at all, right? Because that's where your vertical asymptote is. It makes perfectly good sense. So your graph, therefore, is going to start over here on the left side at around -5 and go through -2 and then down to your asymptote there. And likewise, it's going to start close to your asymptote at 0, and then it's going to curve down and go towards 5 on the right. Okay, and that's all there is to this one. Nothing else to do. Okay, 28, on the other hand, has a lot of stuff. So let's go through this one a little bit more finely. So here you have your intercepts, or rather your axes. Okay, we have domain restrictions at +2 and +5. Okay, so here it says as x approaches 5, the limit does not exist. So this is your vertical asymptote at +5. So we're going to talk about the behaviors around your asymptote. So to the left of to the left of 5, it goes down, okay, to -infinity. To the right of 5, it goes down also. So both of these around your asymptote, the graph is going down. Okay, so our next one here, if x approaches 2, is going to be +3. This is telling us that there is a hole here. Right, whenever your y value is a number for a domain restriction, we're going to have a hole. So we have a hole at the point 2, 3. And our next one, this is your horizontal asymptote. The limit as x goes to infinity is +4. So we put on our horizontal line, a happy little horizontal line, Bob Ross would say, right there. And now we talk about your intercepts. We have +4 and +6. Both are intercepts, and they both have multiplicity of 1. And then your y-intercept is 3.5. So right there is where it crosses your y-axis. So with all of that, we can sketch. So we start next to our asymptote on the left, maybe a little closer. Okay, go through 3.5 and then jump over your hole. Go through +4 and go down to your asymptote. And then come up from your asymptote, go through +6, and then go out to the right. And that's the graph that we are looking for these attributes from your rational equation. That's all. Remember, if it does not exist, the limit as x approaches number does not exist. That's where you get your vertical asymptote. And if the limit as x approaches a number is a number, that's where you have your hole.